Hey everyone, my name is Dave. Welcome to the NTDRacing Speed Shop. Behind me is the front end of our budget trophy truck we're calling Lefty, and today we are working on all the dimensions for our steering system for the long travel suspension. Behind me you see that computer. We're going to be spending a lot of time on that thing, fleshing out dimensions and making sure we're not going to have interference with other parts. Let's go ahead and get right to this build.
All right, so this is what the finished product of this video is going to look like. It is a long travel steering system, and it basically lets me hold the geometries for the steering as the suspension goes through about 22 inches of travel. And it also does it on a budget at about $100 worth of parts here. So what you're about to see is some of the fabrication for this. And then also there is just a whole bunch of CAD, like you can kind of see here. But I put the full version, which is probably over an hour long, at the very end of this video if you want to know how I flesh out all the numbers and get all the dimensions to make these parts. And then I put those into the Langmuir Systems CrossFire XR, like you see here. And what an amazing machine, just cuts out perfectly dimensioned parts. If you think you'd like one of these in your own shop, then code NTDRacing at checkout will save you about $100. You can see a ton of videos I made about the CrossFire Pro and the CrossFire XR, and that is linked in the playlist below. Just a short montage of some of the fabrication, and then now you get a chance to see all the parts that we dimensioned and made with Fusion 360, which is all at the end of this video.
Okay, now we got everything ready to go. Let me show you what we got. This is 1.5 inch, that's square tube. You can see it's ground down specifically on one side. Here is another one, and what this one is going to do is going to set basically the distance for one part. Is going to set the distance between the two rod ends that are going to make up the tie rods, and you'll see how all that goes together in a second. But with that, this thing does, more importantly, another square tube, which is just slightly wider than this one that I ground down a little bit more. It's going to set basically help me maintain everything in square as I put this thing together. So let me show you how this will all go together here. First thing is I got the top plate, which is upside down right now. I'm going to use some playing cards basically just to maintain some clearance. Each playing card is about 10 mils, so this would be about 20 mils or 20 thousandths of an inch of thickness. I'm going to set the slider over top of it because that's what basically is going to maintain the thickness there. And then I'm going to put this slider here. You can see I cut these, I basically radius these with my tube notcher, but I left this end on basically to maintain that greasable area there and also give me a place to put the boot on. That'll make more sense later on once I put this whole thing together. Put these plates on the side, and then these tubes right here, when we're all said and done, these, which are 3/4 inch on the inner diameter, 1.25 on the outer, 1/4 inch wall will weld up to here, and this will be where the bearings all will mount to. And then as I kind of clamp this thing together, and I flip it over, get rid of these cards, put this plate back on. This is where this plate will weld, and then now you can see this slider will slide nice and easily in between those plates, and once it's greased up, it's going to go really nicely. And then you can just imagine the fact that it is hydraulic force pushing it there, and there's not a lot of play in there, a whole lot less play than we had in HONCHO, and HONCHO's worked really well. So this design has let me tighten everything up just a little bit as far as the design goes. So let's go ahead, let's do a finish weld on this thing, and then we'll go ahead and mount it onto the front end of the chassis so you can see how that's going to go together. All right, let's look at the finished product for what I call part one is done of the steering system. And so what we got here is the slider. And the only thing left I really need to put on it that isn't on it are these boots. And These boots are there basically to keep the slider clean and also to hold the grease in there. So the slider slides back and forth, and you see I got grease Zerk fittings on both sides and on the back also. I don't have any on the bottom. We just usually grease the snot out of this thing before we finish put it together. But how it's going to work is you're going to have a steering box sitting right here, and that'll be made in the next episode. It's going to have a pitman arm right here with another rod end. It's going to be pushing and pulling on this rod end. This rod end slides the slider back and forth. The slider moves these rod ends, which are connected to the tie rods, out to the spindles. And they are the perfect geometry for the short, long arm suspension that we are using for this setup. So the slider goes back and forth on this 1.5 inch square tube to this 1.25 inch quarter wall tubing. Same thing over here. And then this part over here is the last thing you saw me doing, which this plate right here, which is the same as this one over here, just sets the geometry between these two ends here. Yeah, the bolt doesn't go through. I need to get some 7-inch bolts for that. And then the rest of the stuff is just plating. I just kind of put it in there, which just welds across the top, welds across the bottom, welds across the center so we don't get water inside there when we wash this thing. And this stuff was really easy to make. And I did MIG weld. I don't usually MIG weld. I TIG weld most of my stuff. But I was just trying to get through a little quick. And I just want, I'm trying to get to be a better MIG welder. I don't think anybody's calling me to do any MIG welding jobs after seeing this thing, but it will work. It'll hold it together, and I think this thing is going to be pretty durable, at least as durable as Honcho's, and Honcho's has been bulletproof for us. So the next episode, we're mounting the steering box, we're making the pitman arm, and finishing out the steering system for Lefty. So there you go. All right, we're getting right to it. We're going to start with part 2, getting that steering box in there. A little bit easier, not as geometry intensive as this one was. Stay tuned and watch as we put the steering box in, get the pitman arm in, and get all the other stuff, because after that we're doing lower suspension arms, upper suspension arms for Lefty. Hopefully that sounds interesting to you, and you will hit the subscribe button and ring the bell so that you'll get notifications of the future episodes. Every time you leave a like, it shows this video to more people, and we sure do appreciate it. It definitely helps us out. We'll see you next week. Take care of yourself.
All right, I've been trading this video because there's just a lot of stuff to kind of go through on this one, but here we go. Here is our truck, and if you don't remember this, you can kind of go back to how I brought these pictures into one of my Bentech videos, and I dropped this in. This is the file that we made on Bentech for the whole truck and how it's going to look. We dropped it into Fusion 360 so that we can kind of pull a little bit of dimensions off it, and so that's what that looks like. And I overlaid from Race Aspirations. There's a discount code, I think, on one of those videos for this program, which kind of gives you the suspension geometry and all that kind of stuff. I've overlaid that over top of this thing, so you can kind of see when I show you my next picture here what I'm looking at. Lower suspension arm, upper suspension arm, and then just here's like the distances between those, from here to here, between those two, and then the steering arms too. And those aren't going to be exactly where they're going to be located, and I'll explain more later as we kind of go into that. And I kind of go over to the front here of Lefty, and this is basically that same picture. We got an upper suspension arm and we have the lower suspension arm, and I just basically put these points in here. These will be hard points that we kind of got to work off of. You see these lines right here in between the two, and that's 17.24 inches, and those will be important, especially as we go in later to locate our steering, and basically from the information that we found off of Shock Therapy and their videos on how we basically put the steering in there to do our best to minimize bump steering. We'll talk about that a little bit more as we kind of go through it. I don't think we'll get to the spindle side today, but we'll definitely get to this side of the steering and how we're going to locate all that. So to pull these dimensions off, I kind of went to some of my older Fusion 360 renderings, and it kind of gave me those dimensions there. I pulled those off and I put them in here. This is the spindle side over here. I have the entire width of the truck is 90 inches, so 45 inches to the end of the tire. The tire to that spindle is about 14 inches, almost exactly. So I just put a nice round number of 14. And as I work out my way out the other way, with the 4x4 inch square tubing, this mount right here is 1.25 inches by 1.25 inches up, and that basically gives us a 27.75 inch lower suspension arm, and kind of the same math kind of works for the top, where we get a 16.606 steering. So let's talk about just some of the numbers I had to flush out for the steering.
And first thing I had to do was work on what's called acromate angle. And if you don't know what that is, probably worth it. It's pretty easy to look it up to figure it out. But if you don't account for acromate angle, it's basically like, let's say you make a left-hand turn. Well, your left-hand tire makes a smaller circle than your right-hand tire. We're talking about the front of the truck. So it's basically the steering geometry accounts for that. It allows you, as you turn left, it turns out left tire more than the right tire, and accounts for that. So the way you do that, if we kind of go back to this picture and look at the top of the truck, as we take the distance from the center of the truck out to this, where it rotates on that spindle, as one of the legs of this axis, and the other one being the how long the truck is, which is 128 inches. So here's our 128 inches by 31 inches from the center of the truck out to where that spindle is going to turn. And what we end up finding is that this angle right here equals 13.6 degrees. And so what that means is that if this is where my uniball is going to be at this point right here, then my steering has got to be back 13.6 degrees where I mount my tie rod. And so it's basically a little bit more into the wheel, if you will. And so what I'm going to shoot for, I kind of put some different dimensions up here and how I would use those. And what I'm going to end up using is this one over here, which is, we're going to set it from the center. We're going to set it off 5 inches, which eventually gives us this resultant, which is 1.21 inches. And you can kind of see that here. Again, here's the center of the truck. Here is the tie rod, and it's going to come over. So this would be, you're driving straight ahead, and it's at 13.6 degrees. The wheel is actually going exactly forward. And then now the distance that thing is back from center is 1.21 inches. Now here's the other thing is that, well, how much does the tie rod have to move left and right to make that happen? Because that's going to be important as we kind of make a slider there. So the tie rods will in general, the uniballs, they kind of max out at about 32 degrees. With your best geometries, about 32 degrees is all you're going to get out of those. So as I rotate this thing 32 degrees, I push that tie rod over, and it moves my wheel 32 degrees to the left. What I do is I come down here, and I find that tie rod, to make that happen, it had to travel 2.467 inches. So that's how far that tie rod's got to be able to move to the left. And if I'm going to turn to the right, that same number of degrees, 32 degrees, then it would be 2.864 inches. Now realize it wouldn't turn the same because it's going to turn less to the left than it would to the right. So really about 2.5, and if we kind of round up, say to just 3, just to make sure we have enough slop in there to while we're making that'll be a pretty safe place. So we need to make sure that tie rod slider that we're going to make can travel about 3 inches. And as I'm going through these slides, I think I'm going through them pretty quickly. And the reason is because this video could take forever, and I've already kind of made all these geometries. And what I would recommend is after we're done with this and you kind of see how it all went together, you're like, man, how to get that number? Kind of go back to the video, the beginning of this video, and you can kind of see where these numbers all came from. So that's a critical number. The slider needs to be able to move left and right about 3 inches. And then one more thing over here, you're like, oh my God, that's a mess. Well, what I'm looking at here, if we go back to the Lefty picture, is now we're kind of, let me flip it back up this way and then rotate this way and actually rotate down so you can kind of see. We're looking in this way now. So I'm looking from the left side of the truck, and I'm kind of looking at this tube right here, if you will. So this tube right here is the one I'm going to be talking about right now in this picture right here. That is represented by this tube right here. And so what I've done here is just like, I can do math all day long, but sure is nice to have the computer flush it out because you can kind of see things in there and see if you forgot a dimension. So basically what's going to happen here, I'm going to talk through it. It's not going to make any sense, but when you come back after seeing me build it, you're like, oh, that makes some sense now. So here's that tube. This tube right here is going to be a 1 1/4 inch round tube, DOM, with a 1/4 inch wall, which is going to let this right here, which is a 3/4 inch bolt, slide all the way through. And what that's going to do is it's going to stop right here, and this is a part that's like this plate right here. You kind of see some 3/16 inch plates right here are going to mount to the truck, and then from there the slider is going to mount, and inside the slider it's going to be, which you kind of see represented here by this 1 1/2 inch square, which is a 1 1/2 inch square tube that goes, from one side of the truck, or the steering system to the other. And that's going to be basically mounted onto another one of these pieces of 1¼ inch round DOM tubing. And so that bolt will hold those whole things together and it'll be pretty rigid. This piece right here represents the slider, which is going to be going over this tube right here. And then right below the slider will be another 1¼ inch tube with a bolt going through it. And right over here on the very end will be where our rod end is going to mount, and then our rod ends will go out to the tire. Because I really need to know what's the center of the steering. So let's go hotkey L again for a line. We'll start at the bottom, and again, the minimum distance here to that center line is 0.75 inches, which makes sense. So again, let's give ourselves 3/4 inches of slop. Both of those will work. And we'll come back over here and we will start at 1.5 inches up from the bottom. Obviously, I've practiced this one time. So anyway, there it is at 1.5 inches up from that square tube, which is the front. That kind of makes this the front of Lefty. All right, I'm going to go leave my construction lines on. I'm going to hit hotkey L so I can start drawing a line. And now what I'm going to do is, if you watch the folks over at Shock Therapy, they talk all about how the steering is going to be. Basically, the steering needs to have the correct geometry, needs to be located on this line, which is in between the 2 pivot points, and on this line, which is the 2 pivot points. And the ratio that is up here needs to equal the ratio it is over there, and we'll work on that later. But right now, we kind of see as we bring that line over to there, that's where the steering should mount. Now, remember that we decided that the steering for Ackerman angle, it needs to actually have an additional 1.21 inches. So let's say 1.21 inches. And that is where our tie rod is going to mount. Likewise, on the other side, when we find this spot, I'm also going to move that out 1.21 inches. Now, I don't think that that's going to create bump steer. It might, and if it does, I'll be the first one to tell you. But I think that just by shifting that over there, I haven't totally messed up the geometries, as long as I stay in the spirit of kind of where those things are supposed to be located. I'm going to hit hotkey C now. I'm going to grab this, turn construction lines off. And now I know that this right here is actually a 0.75 inch bolt will be going through there, 3/4 inch bolt. What's going to go over top of this, so the hole that goes through there is 3/4 inches. I'm going to hit hotkey C, and the tube that's going to go through there is that 1/4 inch wall DOM, so it's 1.25 inches will be that tube. And that's what's going to hold that thing on there. Now that slider, that tube is going to be held on in the square tube that goes through there. And I'm just going to represent it by a square. And I realize it's going to be a full tube that goes in between the 2 tie rods. It's going to be 1.5 by 1.5 inches. So continuing on with this geometry, this is where the tie rods are going to be. And then on top of that will be the slider. So we're going to hit hotkey R again, and we're going to make, just with the slider, it's going to be a 1.5 inch tube. I'm just going to put 1.5 by 1.5. Obviously, I'm just using these dimensions just to kind of flush out a location where stuff's going to go. So that slider is going to represent, the midline is going to represent where the mount is going to go. So I can actually come in here and hit a hotkey L, turn on construction lines. And I'm going to go out here and just kind of put somewhere out here on this line is where the slider is going to mount, the tube that everything's going to slide over. Now remember, there's a couple different things that we got to do. So we've got these rubber boots, and you'll see them while we're putting together, that kind of go over this slider right here. I'm going to make a 1/8 inch flange. Hotkey R, and the important dimension is 0.125. Cool. So now we know that this is as far as the geometries of the slider is going to be. Now we need to know how far over is this slider going to go. Well, we said already in there that we needed to go about 3 inches. So hotkey L, let me escape out of that, get in here so I can see it. Hotkey L, so right from the end of the slider, I know this thing needs to go 3 inches. And then for the compression of the boot, if I just go ahead and I'm going to give it 1 inch, and I know it's going to compress that thing a whole bunch, but realize we don't spend a whole lot of time lock to lock with that thing completely compressed. And that rubber can compress down to about 1/2 inch. And we're not going 3 inches, all those kinds of things. There, I'll show you why that was a compromise here in a second. So I'm just going to go out here 1 more inch. And that is what that inch is what I'm giving for the compression of the rubber boot. Now I'm going to say hotkey C. I'm going to take away some of that compression. This is going to be an actual circle. I'm going to say 0.75. That's where the 3/4 inch bolt is going through. Hotkey C again, and we're going to go out to 1.25 inches. This is that 1/4 inch wall DOM tube that's going through there. And that is where this whole slider is going to mount. And you can kind of see it sure doesn't give a lot of room for that boot to compress, but I think it's going to be okay. We've beat it up, and since I'm making the slider a little bit different, if we need to replace those, we can. So the reason that is important, and why I kind of, before I gave that thing 2 inches and it was all the way out here, let me kind of show you why I stopped doing that. So really quick, this circle right out here represents the arc that would be the suspension arm as it goes all the way around. And as we kind of talk about clearance and interference here, this 2-inch circle represents basically the bearing, if you will, that's going to go on to hold that part of the suspension. All right, hotkey L, out to the circle, just missed that little thing down there. Then you can kind of see here's the clearance we would have for that. And then hotkey L again. I'm going to come down to about where that suspension skin is going to be, and it's going to be right about here. You can see it's giving me about almost, depending on where I'm mounted, about just about 12 inches of travel before that suspension strikes the tire is going to travel upwards 12 inches, and that's more than I had planned for anyway. So I was going to bump it somewhere around 11 or 10 inches in the up, and then 11 or 10 inches in the down, giving us about 22 inches of front suspension travel. So right now, with where everything is located, we have all of the clearances that we're going to need. So we're going to go ahead, Control Z, and get rid of that line also. Now let me show you kind of what this thing is going to look like. I'm going to go right off the top of this tube, and I'm going to come all the way into the center. It's going to be a straight line all the way across. Make sure, yep, there it's 90 degrees. And then I'm going to come over here, and what I want to do is I got to preserve that clearance there. So what I'm going to do is I'm going to start with a construction line, and I'm going to just come down here and make that one tangential, and then I'm going to come up and make that. What that will be is that I'm going to basically make it to where this plate, a 3/16 inch plate, which is going to give it all of its rigidity, will travel across the bottom. But what I want to have happen is I want this thing to be, I'm going to say hotkey L again, start right there. I'm going to move up 0.1875 inches, and then from there I'm going to say hotkey L, and I'm going to bring that in parallel over here to the side of this circle. Turn construction lines off. All right, now that I got all this stuff, I'm going to go ahead and cut out the parts that I don't need on here. So I'm going to cut the circle off. And then in general, what I'm going to do is I'm going to take all these lines, I'm just going to mirror them over to the other side. So I'm going to go to Create, I'm going to go to Mirror, and grab all these lines that I want. And I'm going to say, I'm going to mirror them on this line that I put in there, and I'll put the other side in, hit Enter, and it should make one complete piece there. I'm going to go ahead and take out all this stuff here. All right, so sorry about speeding you up there. I had to just do some work here without my brain talking the whole time. So anyway, what I did is I added these holes in. These are basically going to be some rosette welds where I'm going to reach out, and this represents those round tubes that kind of go up. And just another place for me to kind of grab a hold of this frame with those. So I'll just basically put some welds on there on both sides to shore this up, and then it'll be a big plate on the top and also a big plate on the bottom to kind of make this whole thing rigid. Besides that, I think we can go ahead and hit hotkey E now for extrusion and say let's extrude that part. I want to extrude that and that also, so because that hole, I want to leave that there because I need that for my next thing, which will be the slider I'm going to make. But right now, we don't need that geometry on there, and I'm going to say it's going to be 0.1875. 0.875 for a 3/16 inch steel, and there is the piece we're going to make. Let's go ahead now. We're going to make 2 of these, so we can take that and we'll go from CAD, computer aided design, over to manufacture CAM, computer aided manufacturing. One of the cool things of Fusion 360 I've always liked. We'll go to setup and say we're going to cut this thing. We'll set the box point. This is where I always set my still, on the top left, and I work down to the bottom right of all the still that I use. We're going to go ahead and call this the steering mount plate. And now we're going to go over to cutting. And I'm going to select a tool. Again, I use the Langmuir Systems CrossFire XR, and I used to have a Pro, and we always used the Razorwell 45. I'll tell you what, I love the thing. I always said I was going to get a hypertherm when this thing gives up on me, but it never has. 3/16 inch still. I should probably have written these numbers down, but I'm going to guess I'm going to cut it about 65 inches. I'll probably use my lead in at about 50, and then I'm going to lead out. I always go faster. I try to get out of it fast. I leave it less of a mark as I'm kind of exiting. I'm going to cut this thing right here. I'm going to go over to this, and I set 0.05 for the radius. I always come in at a 90-degree angle. And the lead-in distance, I try to make it as big as I possibly can. In this case, we got a 0.4 inch holes on the center. So if I just say 0.2, I think I had almost 0.2 on there anyway. That's probably pretty good. And then as far as like where do I want it to start the lead and cut, you know, I generally just usually pick something that if it leaves a mark, it's going to be easy for me to weld over and grind over and all those things to hide it. So I say okay, and it should generate the path. And it's kind of one of the things you want to pay attention to, is that it actually made a tool path for all your holes. If I had made that lead in too long, let's say I made it 0.4 and it was going to try to fire over here, come over and make the hole, it just would not have cut those holes. So you want to make sure that all of those are good. And then from there, I'm going to drop the G code into my folder for Lefty. So I'm going to select the folder I want it to go to. There's my Lefty folder, and I have a steering folder, so I'm going to select that one. I was cutting 1/4 inch plate last time, and I had a 0.3 for pierce delay. I'm going to say 0.2 works pretty good for most steel. Less than 1/4 inch, and there we go. I'm going to post that. Now it's ready to go over to the CrossFire XR and cut this thing out.
So after making those first few plates, which basically just hold the slider assembly in place, now we're actually going to make the slider with these things. So we're cutting this again into 3/16 inch steel, and I took the dimensions from the previous screen and dropped them in here just so I know exactly what the distance is between basically the 2 circles that you see that we're making on here. And then you just got to make it fit around 1.5 inch square tube. The really cool thing about this is that the square tube that's going to be inside there holding those 1.25 inch tube piecage, which basically holds all the rod and super strong stuff, is going to be 3/16 for that metal tube, and then 3/16 for these plates. So basically 3/8 inch steel, all welded to those 1.25 inch DOM tubes. It's going to be pretty robust and pretty strong. I think equally as strong as the one that we were using on HONCHO. From there, I go ahead and just make the top. I need to account for the width of the 1.5 inch square tube, the width of the 3/16 inch plates that are going to go on both sides, and then also give myself some room to weld on the very top of this thing. So, and then one last feature I'm going to add on to this is I think that having a continuous piece where that tie rod is going to mount is a lot better than having to weld one on. So I'm going to integrate that into the design of this top piece, so I don't have to go in and weld another piece in later on. So at least half of the mount for that tie rod is in this one. And now we're ready to take all these parts over to the Langmuir Systems CrossFire XR and get them cut out. And again, if you think you could use a machine like this and you like this kind of fabrication, you can go to our webpage at NTDRacing.com and find out all the information about the Langmuir Systems CrossFire XR. I got information in our playlists for all the CrossFire XR and the CrossFire Pro, and then again, code NTDRacing will save you $100 if you're going to buy one of these tables from Langmuir Systems. And I think they're great, so I have no problem recommending their products.